Hello everyone, this question is for NEET from projectile motion, and in this question, the question is a particle of mass m is projected with velocity v making an angle 45 degree with the horizontal. When the particle lands on the ground level, the magnitude of the change in its momentum will be option A is given as mv root 2, option B is 0, option C is 2mv, and option D is given as mv divided by root 2. For solving this question, first of all we have to take a mutually perpendicular coordinate system. Let the x-axis is taken as horizontal and y-axis as the vertical axis. And the projected particle is projected with a certain velocity v, which is making some angle theta with the horizontal ground level. And acceleration due to gravity is always acting downward in projectile motion. And if we divide the acceleration due to gravity into horizontal component as the acceleration due to gravity making angle 90 degree with the horizontal level, therefore the component of g in horizontal direction will be equal to g cos 90 degree, which is equal to 0. Therefore we can see that there is no acceleration in the horizontal direction in the entire projectile motion. Now if we divide the velocity v into two mutually perpendicular components, then its horizontal component will be equal to vx, which is equal to v cos theta, and the vertical component of the projectile is vy, which is equal to v sin theta. Now in its trajectory of the projectile motion, it will take a parabolic path, and after completing its path it will again reach to the ground. But as the acceleration due to gravity is always acting downward and the vertical component of the velocity is always acting upward, therefore g, or acceleration due to gravity, will always try to nullify or minimize the vertical velocity component. But as there is no acceleration in the horizontal direction, therefore this vx, which is v cos theta, which is always given constant or uniform motion. Therefore after some instant of time, the velocity vx will be same. There will be no change, but the magnitude of the vertical component of the velocity will some less amount as previous one, and after some instant of time it will be more lesser, but still this vx is same, and at the maximum point, maximum height, the vertical component of the velocity will become 0 or it will be diminished, but still the vx is constant or it will be unchanged. After getting the 0 velocity of vertical component, therefore it will take negative value or it will increase negatively. So the direction of the velocity, vertical velocity, will be reversed. It will be equal to vy in negative direction, but still this vx is constant, or there will be no change in the horizontal component of velocity. And after some instant, when the particle or projected body reaches to the ground, then its velocity, vertical velocity, will be downward, vy, and as it is downward, so its direction, unit vector, will be equal to minus j cap. But still the vx is unchanged and it will be again vx I cap. So initially its vx is equal to vx I cap and vy equal to vy j cap. So if we take the momentum, initial momentum, then its initial momentum of the projected body pi is taken as m vx I cap plus m vy j cap. It is the initial momentum of the projected body, and the final momentum pf is taken as m vx I cap plus m vy minus j cap. Now if you consider the change in the momentum, therefore del p, or change in momentum, will be final momentum pf minus initial momentum pi, which will be equal to m vx I cap plus m vy minus j cap minus m vx I cap plus m vy j cap. So if we calculate this, then we get this mvx I cap and minus mvx I cap will get cancelled by each other. Then ultimate change in momentum del p will be equal to m 2mvy minus j cap. Now if we put the value of Vy, then we will get del P will be equal to 2m V y is equal to V sin theta, and angle is given as 45 degrees. So therefore it will be 2m V sin 45 degree and its direction is equal to j cap. Therefore we can write the change in momentum del P. We will take the modulus of change of momentum, then it will be equal to 2mv and value of sine 45 degrees equal to 1 divided by root 2 and its velocity, and if you take the modulus then the direction will be eliminated. Therefore we can write the change in momentum mod del P will be equal to root 2 mv only. Now from the given options, this option is directly matching with the option A. Therefore the correct option is option